All right, in this video, we're going to continue solving, or simplifying rather, complex fractions. So picking up where we left off, example 1, part C, we have in our big numerator 1 over x plus y over x squared. In our big denominator, we have 1 over y plus x over y squared. Now, this example has more than one variable that we're working with, and that's fine. We can handle that. But looking at our x's, let's first find the least common tiny denominator with the x's. For x and x squared is going to be x squared. Now for the y's, it's going to be y versus y squared is going to be y squared. So our least common tiny denominator is x squared times y squared, or x squared y squared. So if we multiply every single term by x squared y squared, guaranteed no more tiny fractions. So let's do that. 1 over x times x squared y squared. This x is going to cancel out one of these x's, and we'll have xy squared. And then plus y over x squared times x squared y squared. This x squared and this x squared are going to cancel out. And then y times y squared gives us this y cubed in the upper right. Next up, bottom left, we have 1 over y times x squared y squared. This y in the tiny denominator is going to cancel out one of these y's. So in the bottom left, we'll have x squared times y. And then x over y squared times x squared y squared. This tiny y squared is going to cancel out that y squared. And then x times x is x cubed. So we have xy squared plus y cubed over x squared y plus x cubed. However, we're not done yet, because in our numerator, we can factor out a greatest common factor of y squared, since both terms have a y variable. So we can factor out a y squared out of the numerator, and likewise we can factor an x squared out of the denominator. So when we factor a y squared out of the numerator, we're left with y squared times x plus y. And then factoring out an x squared in this denominator, we're left with x squared times y plus x. Now, x plus y and y plus x are going to be the same value, because it doesn't matter what order we add two variables. So x plus y over y plus x, that's going to divide out to 1, and all we're left with is just y squared over x squared. So as big and nasty as example 1c started, it ends with just a y squared over x squared. All right, example 1, part D, we have x over y and then minus 1 in our big numerator, and then x squared over y squared minus 1 in our big denominator. Well, our tiny fractions, our tiny denominators are y and y squared, so our least common tiny denominator is y squared. So we're going to multiply every single term, all 4 of them, by y squared. When we do that, x over y times y squared, this tiny y is going to cancel out one of these y's, leaving us with just x times y in the upper left. And then 1 times y squared is y squared, so we have xy minus y squared in our big numerator. In our big denominator, x squared over y squared, when we multiply that by y squared, the y squareds cancel out. So in the bottom left, we got an x squared, and then minus y squared. And again, if we look at our numerator and denominator, our numerator we can factor out a y, and then our denominator, x squared minus y squared, that factors as a difference of squares. So our numerator, when we factor out a y, we get y times x minus y. And then x squared minus y squared factors as x plus y times x minus y. So we have an x minus y as a factor in the numerator. We have an x minus y as a factor in the denominator. They're going to divide out to 1. And our final answer is just y over x plus y. All right, part E, we have 1 over x plus 7 and then minus 1 over x. And that whole thing is all over 7. So here we have an x plus 7 in the denominator and an x. So these are two completely separate denominators here, which means our least common tiny denominator is just a product of x and x plus 7. So we're going to multiply all 3 terms, the 2 in the big numerator and this 7 in the big denominator, all 3 terms by x times x plus 7. So when we do that, 1 over x plus 7, multiply that by x times x plus 7. The x plus 7s will cancel, and we're going to be left with just an x. 1 times x will give us x. Then we're going to bring down the minus, and then 1 over x times x plus 7. These x's cancel out, leaving us with x plus 7 in parentheses. And we got to keep it in parentheses because we have to bring down that minus. And then 7 times x plus 7. Just for right now, I'm going to leave it as 7x times x plus 7. Now, distributing our negative in the numerator, we get x minus 7 over 7x times x plus 7. And combining our like terms in the numerator, we get negative 7 over 7x times x plus 7. And then negative 7 over 7 is negative 1. So we have negative 1 over x times x plus 7. All right, example 1f, we have x plus 1 over x plus x plus 1 over x minus 1 all over x plus 2 over x minus 2 over x minus 1. So this one, we have x and x minus 1 as our least common tiny denominator. And multiplying everything by that, our upper left one, the x's are going to cancel. So we'll have x plus 1 times x minus 1. And our upper right term, the x minus 1's will cancel. So we'll have x times x plus 1. And then our bottom left term, the x's will cancel. So we'll have x plus 2 times x minus 1. And then bring down the minus. And our bottom right term, the x minus 1's cancel. So we're left with 2 times x. So multiplying this out, x plus 1 times x minus 1 is x squared minus 1. And then plus, distributing this x, we have x squared plus x. Then in our denominator, x plus 2 times x minus 1 is x squared plus x minus 2. And then bring down the minus 2x. Then combining our like terms, we get 2x squared plus x minus 1 all over x squared minus x minus 2. Well, we can factor the numerator and factor the denominator, and when we do that, we get 2x minus 1 times x plus 1 in the numerator, and in the denominator, we get x minus 2 times x plus 1. Well, our x plus 1's are going to cancel out, and it's going to leave us 2x minus 1 over x minus 2 as our final answer. All right, so that was quite a bit of work there. So that about does it for this video. Thank you for watching. I'll see you next time.